Welcome everyone to this week's episode of the Uplink. My name is Mark Phillips. I run business development here at Helium. We've got Christian and Fleming here and Adam from a company called Stoffl. We'll get into exactly what Stoffl is in a second. And I think we're going to run, our pretty standard 30 minutes here with some Q&A. We like to take questions during the middle of the presentation. So if people have questions, please drop them in the chat and we'll try to take them sort of as they come in. And if we don't get them as they come in, we'll do, like I said, a good dedicated Q&A at the end of this entire thing. General order of operations for today. So I'll do a brief overview of Helium for people who might be new to the ecosystem and the network and the project. But we'll spend the majority of the time talking to Christian and Fleming and Adam about what's happening with Stoffl and what they're building on the network. So that is what we're going to do. I'll do the Helium intro first, guys, and then I'll jump over to you guys for introductions and off we go. Sound good?
Mm-hmm. Yep, thanks.
Cool. Okay. So we talked about the agenda. So about Helium. So we were founded in 2013, which is actually just before I joined the company. We're funded by big name VCs that you've probably heard of: Coastal Ventures, First Mark Capital, Google Ventures, most recently Union Square Ventures and Multicoin Capital, who led our C round of funding in 2019, which actually seems like ages ago at this point. What are we, like 2021 at this point? Long time ago. And so they and all of our backers and the entire community are now fully sort of invested in building what we call an incentive built network. We refer to as the people's network as well in a lot of places. And so this is really the differentiator when it comes to how Helium builds out what is ultimately the world's biggest LoRa network at this point. We've built this remarkably innovative incentive model that the Stoffl crew will sort of talk through and focus on their use case, of course. And this is what really enables the Helium ecosystem to build, like I said, the largest LoRa network in the world to date. I've got some stats I can show you on the Helium Explorer momentarily about how quickly we're growing, but I think we're just about to hit 23,000 hotspots on the network, which is pretty remarkable. I think we're adding about 1,000 every 3 or 4 days at this point, and that number is still slowed down by lack of hotspot supply, which is unfortunate, but will be alleviated relatively soon. And so on the topic of hotspots, when we talk about building the Helium network, we're looking at gateways that look like this. So from ecosystem vendors like Bobcat and Nebra and Syncrobit, those are relatively new ones. Then there's the Rack hotspot miner, and then the original Helium miner, hotspot miner rather, this glorious sort of white square with the black circle in the center, which is no longer being produced, but if you work pretty hard, you can sort of find them out there. The Helium network, as I mentioned, is the largest LoRaWIN network in the world. We combine this with the Helium blockchain into something that we call LongFi. So there are plenty of other LoRaWIN networks that exist in the world. None of them have been built out as quickly as Helium due to the fact that we've built this incentive powered infrastructure, and that is LongFi. That's a combination of the Helium blockchain, something brand new that we built from the ground up to basically confer certain properties on physical hotspots, creating a wireless network in the physical world, combined with LoRaWAN, which in our opinion is the best way to send long range, small device data from things that we'll talk about with the Stoffl team, for example, today. And let me, oops, sorry, lost control again here. And so when we think about why companies like Stoffl are using the Helium network and deploying things at scale, they're doing it for a variety of reasons. It is things like being the largest public IoT network in the United States, and like I said a second ago, I think we're the largest public IoT network in the world, especially LP WIN network in the world. The accelerated rate of coverage, right? So we've built the network out at a rate of 5 times over the last 9 months, and that's just accelerating. The number that we have today, 22,000 hotspots, will be a relic very, very soon. When we talk about costs on the network, so the network charges transaction fees for every packet that you send from a sensor. In our case, the cost of those transaction fees is remarkably low, to the tune of about $1 per sensor per year for some fairly standard sort of IoT use cases. We can use any LoRaWAN sensor in the world on the network. The Stoffel crew will talk about what they're building specifically for hardware. Their use case is interestingly custom and requires them to build some of their own hardware. But for a lot of use cases, and a lot of the episodes that we've done in the past on the Uplink, people are using off-the-shelf LoRa WAN hardware from the ecosystem of hundreds of vendors out there. And Helium supports all this hardware out of the box. And then the Helium blockchain provides the ability to do proof of time and proof of location for sensitive data. So we actually haven't talked about this too much, but I imagine Christian Fleming, you guys might actually start using this for your use case. Maybe we can get into that a little bit. The idea that the blockchain sort of gives you provenance of data coming across the network. And so to sort of round off things here, some of our customers that we've sort of recently talked about are Nowie and Conserve, for example. We've got webinars out there from both of those companies. Caravan, we also did one recently. We announced a great partnership with a company called Victor Mousetraps yesterday, the world's largest mouse and rat trap manufacturer that now has a connected trap on the Helium network. So if people haven't seen that announcement, check out the Helium Twitter or the Helium blog for details on that. Okay, so let's get to the more exciting stuff today. So I'm going to kick it over to you, Christian Fleming. I'll let you introduce yourselves, and you've got, well, tell me when you want me to advance the slides, but off you go.
Okay, will do. Yeah, thank you very much, Mark. That was a very interesting announcement you talked about there with the mousetraps. But anyway, it's a pleasure to have you all here today, and we hope you're all doing well. My name is Christian Charalambous, and I'm one of the co-founder and executive directors of Stoffl. My background is in aviation, and I flew Boeing 767, 757, and 737 aircraft around the world, mainly in Southeast Asia, but more recently in Europe. The Boeing 767 that I flew, they were mainly built in the 1980s, and they didn't even have GPSs. They mainly used inertial reference systems to determine their position, and we had to calibrate that before departure. And then subsequently, I reached the Boeing 737 NG, which is a much more modern aircraft, and that was built in the last previous decades. And I essentially saw all the developments in the hardware that happened, and I essentially decided to start tinkering myself and got into IoT, blockchain, and other stuff. So let me just see. I'll let Fleming introduce himself, and then we'll get more into the company.
Thank you.
Yeah, so my name is Fleming, and I'm the other co-founder of Stoffl. And together, Chris and I saw the opportunities within low power networking protocols and the advancements in the unlicensed field. And we saw that there were relevant applications to the maritime and transportation and logistics industries. So just briefly on my background, I come from the maritime industry. I spent a number of years sailing the seven seas, mostly in the capacity of chief officer on board oil and chemical tankers. I have some long distance towing experience as well. And I came ashore as an inspector for the oil and gas industry, and most recently worked as a consultant for high stakes maritime claims cases. I understand innately the difficulties in connecting the remote locations of the world. There's not much connectivity still today out on board the ships that we all sail, or that I sailed. And what I want to do with Chris is bring technology out to these remote locations. And it's not just with industry, but also remote populations and close-knit communities that are cut off from the world. With low power technology, we now have the ability to do that. And what Helium have done is a grand experiment, let's say, and it seems to be paying off well in that if you incentivize people to participate in building an ecosystem, it bears fruition. So that's sort of the founding blocks on and our backgrounds, and I think Chris will go into a little bit on Stoffl and our vision and what the company sort of stands for.
Yeah, thanks.
I think next slide, Mark. Yeah.
There you go. Yeah, so Stoffl provides a bridge between industry and innovation, ensuring a real-time bidirectional flow of knowledge, experience, and practical problem solving. We collaborate closely with our academic partners to ensure research and development is relevant and can be connected to real issues experienced by our industry partners. Stoffl delivers the necessary hardware for development, testing, and deployment of IoT devices for real-world utility and immediate application. Together with our industry partners, we identify the areas that need improvement the most, and we provide tailored solutions to address those through custom hardware and custom solutions.
Yeah, so what we aim to do is mitigate risk to industry by offering a multilateral partnership approach and working side by side to solve real issues and ensure successful deployment. What we mean by that is we want to take on the risk for industry, because what we are is a small dynamic startup that is able to pivot and adapt quickly. And what we can offer industry is the ability to partner with us and our academic partners in order to solve some of the pressing issues that they're facing in real time. By tapping into the universities and our academic partners, we essentially tap into the smartest brains of our time, and we bridge the gap, which is one of the founding principles of Stofl. We bridge the gap between academia and industry, and this is also what we aim to do in other parts of the ecosystems. So Stoffel, with that in mind, we approach all of our endeavors with sort of curiosity at the forefront of our venture into various projects. And that sort of goes back to the founding spirit animal of our company, Stoffel, and that is the one and only Stoffel Honey Badger. And if you're interested, you can search on YouTube for him, but we're big fans, and he's always a good one to watch.
Yeah.
So I think you can go to the next slide.
Yeah. So before we do that, so how did you? So just to make sure that the understanding is clear. So you see yourselves as bringing new sort of bleeding edge technology into industries that generally are slower to adopt it. That's what.
Exactly. So
Correct.
exactly, that's what we've got on the next slide as well.
Oh, okay. We'll get to that. Excellent. And can you give a 30 seconds on how you ended up looking at Helium and ultimately deciding to use the Helium network for? Maybe you're going to talk about this, but like ultimately,
yeah.
I remember
we've
our
got
early
a slide.
Okay, off we go.
Yeah, we've got a slide coming up on Helium, but I'm happy to throw it in there, Mark. The Helium came and fell out of the sky into our laps, basically, and we saw, but we recognized immediately what the concept was within. There's two markets here, right? One is low power IoT, and one is blockchain. You guys merged the two, and that was immediately apparent. And since we launched this company, it's been going in one direction and one direction only, and that's a testament to the model that you guys have produced, but also what we're trying to accomplish, which is to show industry that this stuff is not as scary as it appears to be at first glance. But the Helium model rests on proof of coverage and proof of location, but it's an open and decentralized concept, which we know from firsthand experience is not necessarily a term that is readily accepted by industry. So what we're doing is we're approaching them with a mitigated sort of solution to this by showing them that this stuff is not as scary as it is at face value to them.
Essentially, yeah, exactly.
Yeah.
So then Chris will get into that here.
Yeah. Okay. So most companies, as it says in the presentation, most companies aren't prepared to risk much of their resources to invest in solving the chicken and egg problem that's facing the low power IoT market right now. So by deploying solutions to real industry problems, Stoffel aims to simultaneously grow the LoRa WAN network and ensure its adoption on the industry level. Essentially, by mitigating those risks through our academic partners, we're able to provide that bridge which links the two and mitigates those risks for industry.
Yeah, so what we understand is that in order to develop a truly global LoRaWAN network, it's necessary to involve all the active participants and interested parties within the ecosystem. So we understand, obviously, Helium have started with LoRaWAN, and there's a very real market there for low power devices and the need to connect them. But the blockchain model adds a brand new way for us to build companies and ecosystems together. And actually, I would go so far as to say it's necessary in today's world in order to face the growing challenges that we're facing on a global scale. And what the model allows for, and what Helium have showcased, is that if you provide incentivized mechanisms, you essentially provide the necessary framework for the interested parties, all of them, to come together in a centralized place, even if that is a decentralized ecosystem. They can come together and participate for the positive benefit of that ecosystem. And so that's what Helium have done with the People's Network, and it has, by all accounts, been a massive success so far. And what we truly want to do is ensure the adoption of not only this LoRaWAN network globally, but this model, this new blockchain incentivized model for working together. And I think I'll just round that off there.
Yeah, so
we can go to the next slide.
one thing I just want to add is what industry do currently, essentially because of those risks, they don't know how to mitigate them. What they do is essentially, rather than do the research and development, they just go with what's available, and that saves them cost and it saves them trouble, which is understandable in the end of the day. So what we do is essentially we provide that bridge between academia and industry, which allows them to mitigate that and avoid all those risks involved and the costs involved.
Yeah.
Yeah. So Helium, we'll go back to Helium. We're big fans, by the way, if you can't tell yet, but People's Network, the first P2P wireless network providing a secure and cost-effective way for low-power devices to transmit and receive data. I actually think we copy-pasted this from your old website, so please bear with us.
That was great.
So by combining LoRaWAN and a new scalable asynchronous blockchain, it's now the largest public network in the United States and growing globally. And I think, as Mark rightly said, I believe it is the largest network at this stage as far as LPWAN is concerned globally. So we see the traditional way to build networks is to receive investment and erect a bunch of antennas and provide a service, but this is a slow and very inefficient model. And what Helium have done in the span of a year and a half, 2 years is unprecedented to deploy 20,000 plus gateways. And I think their closest competitor might have some 12 or 15,000 through the Things network, I think it is. But even companies such as Sigfox, who are also developing LPWAN protocols, have only managed to, they've been around for 12 years and managed to cover France and Japan, I think. So at this stage, even with the LoRa Alliance, it seems like LoRaWAN is here to stay and is going to win out on a global level. And that's why Stoffel has set out in this market initially, because we believe both in the blockchain model and the fact that we do need to connect the unconnected, and LoRaWAN provides a very good model for that.
Yeah, so I believe that too.
Yeah, and thanks to the blockchain, all the data that's transmitted on the network is securely encrypted from device to cloud and owned entirely by the relevant organization and never seen by any second party. And as we all know, data privacy is really one of the hottest topics of today, especially with industry. But also with private individuals. And so the Helium system adds that extra layer of secure blockchain-backed platform that allows for industry to have immutable and secure data.
Thank you, yeah.
Yeah, so our challenge is basically the low power IoT industry is experiencing essentially a causality dilemma, which is really just a fancy word for a chicken and egg problem, which we mentioned before. And the problem is essentially that there's no incentive to build the network on a global scale owing to the lack of utility of the actual network. So up until recently, most solutions, they've been proprietary. So Fleming mentioned a couple of those, and they've been in the licensed RF spectrum, which makes them extremely costly, and it really prevents wide-scale development. So without the network, there's no incentive or way to develop the devices intended to communicate on this network. And so the cycle essentially continues. So the open and decentralized nature of Helium's model, what it does is it essentially creates an incentive for the networks to expand globally at a rapid pace. And therefore it promotes the expedited development of device solutions.
Yeah, so historically what we were seeing, as we spoke about earlier, the cutting edge development has been the purview and privilege of military and space industries that are backed by big bankrolls and government. But this is an outdated model. And I think what the true genius of what Helium have done is reflected in demonstrating a new way of cooperating together and showing the fact that there's a new way of doing things, and it's no longer necessary to have an enormous amount of investment to start something. We're now seeing capabilities extend themselves to people such as Chris and myself, who see an opportunity to simply participate and make something successful out of what Helium have done with their blockchain protocol, and extend this to a wider use case and allow for industry and people to come together and work in new ways, essentially. So with that in mind, that's what we approach our industry partners with. And that's, I think if you go to the next slide, Mark. So what we're looking for in our partners are people and companies who share the same vision, that the progress is the purview of all active participants in an ecosystem, and the proprietary solutions stifle development. As far as we're concerned, and here at Stoffel, when something's worth building, it's worth building. And that's what we do every day. We strive to solidify the network footprint and to expand its use through both expanding network coverage and device deployment. And that's what we approach our partners with in order to secure a multilateral approach to problem solving with an open dialogue by finding mutually beneficial projects, which will enable us to progress and develop together.
Yeah. At Stoffel, we inherently understand that in today's world, it's no longer the big fish that define the agenda, but rather the fastest fish that sets the course. The world is really rapidly developing, and with the physical limits of Moore's law potentially being reached this decade, innovations in IoT, cloud computing, wireless communication, and quantum computing should all play an increasingly important role in improving our future world. So if you move to the next slide, please. Our vision, onto the mobile custody gateway. So our vision is to connect the unconnected by leveraging industry's infrastructure and providing a blockchain-backed network to secure data transmission. Safety and security are always really the first priority of industry, of any industry. And that's the approach that we're taking with our mobile custody gateway. Together with our partners at Imperial College London, we're working on our new consensus protocol that will allow for industry's mobile assets to create a secure, dynamic, and truly global network. Our strategy is to connect the unconnected, and we will implement this by utilizing industry's readily available assets, which are often located in remote places without easy connectivity. So I'd like to introduce Adam. He's one of our team members from Imperial College London, and he's working on this project. Go ahead, Adam.
Hey guys, thanks for inviting me on. So basically what we're going on here at Imperial is basically picking up what Mark said earlier, trying to take advantage of the blockchain aspect of the Helium network, trying to kind of get proof of provenance going. So our current main project is trying to detect GPS spoofing of sensor data from cargo devices, trying to there's a fairly minor piece of the whole puzzle, but it's just trying to make sure that sensor data is coming from a place that's verifiable in location other than without using GPS. So kind of by working through the Helium blockchain, so it's a proof of concept to try to get this going. And so we're just some master's computer science students. So it's really great to work with Christian and Fleming, who know much more about the industry side of things, about ships, about planes. Yeah, we definitely found the Helium community really great place to start.
So yeah, so functionally, so let's dig into this a little bit because I think this is the most interesting part. So what you and the team at Imperial College are building is, so it's a prototype that is sensor driven, and you're attempting to basically deliver something, the location of which can be proved without using GPS. That's the fundamental research.
Yeah.
Super interesting.
Yeah, and
good.
we're just using off-the-shelf hardware, which is really nice. So we're just using kind of standard Arduinos and Raspberry Pis and stuff, and really getting good results, which is cool. Okay. And it's been really nice working with Helium because the SDKs, the code, actually not very complicated. Pretty much off the shelf to run something basic here, and we really think there's something interesting there.
Yeah. Okay. And so from so that's the sort of development side. And I guess question for Christian Fleming. So what's the product that gets developed on top of this? What do you end up taking to the shipping company that might deploy this? Or are you not there yet? Curious to see where, how does this get implemented and turned into a product at the industry level?
Yeah, so I can go for this.
Yeah, yeah, go for it.
Go ahead, Fleming. No, you go ahead, you go ahead.
Well, what we're looking to do is build this as a consensus protocol that can tie in the mobile assets of industry to secure a communications network for them. And at the same time, what it will allow them to do using inter-blockchain communications protocols that we're seeing being developed in Polkadot and Cosmos and others is essentially we are seeing the dawn of these sort of protocols being able to migrate in and out of each other. So what we would propose is that there is a people's network that is readily available for industry to use, but they're not going to use it because it's open and decentralized, and these are negative. It's just a negative term for industry. But if we target industry and say this stuff is not dangerous and give them the same protocol, they could essentially migrate in and out of the people's network. And we thus have a use case scenario for truly connecting the unconnected and building an actual global network. So with these inter-blockchain communications protocols, what we're looking at is ways for our gateways to effectively migrate in and out of the stationary network, such as the people's network. And what we're doing is calling these consensus protocols at this stage proof of departure, passage, and arrival. So you could essentially imagine a consensus group that gets elected on some level to certify a ship leaving port. And then the ships, as they engage with each other out at sea, could certify and verify each other's network coverage during passage. And on arrival, the ship and all of its gear and gateways are recertified on entry to a stationary network. And this could extend itself to trains, planes, and automobiles as well. So what we are on track to doing is completing these protocols with Imperial, which would be ready in April. And we're looking at collaborating with the Smart Sound initiative in Plymouth, along with Plymouth University, to deploy these gateways in real world conditions. So Plymouth Smart Sound has 1,000 square kilometers of earmarked playground for maritime purposes. So they have a couple of autonomous ships, some regular ships, some buoys that we can use, and some land-based infrastructure. So our idea is to finalize with Imperial College, and then we're on to actual real-world testing with the University of Plymouth and Smart Sound. And the idea, just to round off, is to provide a dynamic and secure communications network for industry to take advantage of.
That's fascinating. So, God, lots of questions. So there's no, I mean, this doesn't exist now, right? You're talking about building the network to facilitate communication for a ton of applications on top of all these assets, essentially, right? That's what you're sort of driving at?
Yeah, essentially it's a mobile gateway that can sit on a ship or any other mode of transport that brings the network out to where it's not already now. And it opens up the doors to a wide variety of possibilities.
What is the predominant method of communication now from a ship that's steaming across the Atlantic? What are they using? It's satellite, I imagine?
Well, they have Wi-Fi, but it's satellite and it's inherently expensive. I mean, now with Starlink coming, you're looking at probably most of these shipping companies migrating over to that because it's cheaper than what they're doing right now and much faster, which is going to open up completely new opportunities. But the brilliance with LPWAN and specifically LoRaWAN is the long range, which is ideal for maritime purposes, and the low packets, because it's expensive for ships to send data at the moment. But using these low power protocols and LoRaWAN, you could essentially see in a cost-effective way for ships to provide their clients with eyes and ears of their container assets during storage and transportation.
Yeah, that's wild. I mean, this is I guess it's not that crazy that it's not a solved problem yet, because it's fantastically hard to figure out how to do communication in the middle of the ocean. But you would think, given the value of cargo that flies across the ships, that someone would have thrown the money at this to solve it. But super cool.
Well, back in 2004, I already pitched a GPS tracker to Maersk, but it never got off it never took off because I didn't understand at the time the challenges that are associated with the high costs in transmitting data, right? So what LoRaWAN does is allow us to do this in a very cost-effective manner, which has never been possible until a few years ago. And now with blockchain and what you guys have done with the consensus protocols that you've developed, is you've essentially secured a network and allowed people to join and leave, just like a cell phone communications network, which is the only way really I see to provide a global service these days, and that's what we intend to help solidify.
Fantastic. So just a bit of a time check. We've probably got 10, 12 minutes left. So we're doing just fine. So can you talk a bit, let me see what's on this next slide here. Okay, so we talked about a lot of this stuff. Before we leave this, let me ask a question about we can mute somebody. Sorry, so you can make sure everybody's muted here while we're listening. And so the end goal here is to get basically a big, large functioning pilot in the Plymouth Sound, right? That's
Yeah,
correct.
exactly.
And you think you guys will be there in May, maybe?
Well, we've got our
so
Imperial
we've got-
College students. Yeah, they're almost done with it, so they'll be ready with it in April, late April, and then hopefully a prototype by May, and we'll be deploying it down in Plymouth Sound.
No pressure, Adam. You guys should be fine. Yeah. So
But
can
we're
you talk
going by
about
their timeline, so.
Can you talk a bit about the relationship? So, you know, I know you're working with at least more than just Imperial, but the relationship between Stoffel and the university and sort of how you built that.
Well, we just reached out really, and we found, you know, in all of this, it's a search for the right people, right? It's a connection that needs to happen, and just like we did with Helium, we reached out and saw whether or not anyone was interested in talking to us, and lo and behold, if you ask, ye shall receive an answer, and more than one person was willing to listen to our ideas, and so. The problems we came with were obviously of great enough interest for the professors or some of these professors to take seriously, and I think Adam and the group of students working on the mobile custody gateway would agree to a certain extent. I think they might be annoyed at the amount of workload we put on them, but yeah, essentially we were just looking for people to help us, because we again, what we saw in the model that you guys did was there's a new way of doing things, right? There's a new way to bridge the gaps that exist in society. There's a new way to collaborate, and we thought, why not try this in the universities, which was where ARPANET and the rest and the internet was born. Why not see whether they were interested, and they were.
Yeah.
So, yeah, I mean, on top of that, what it led us to was a bunch of other partnerships and collaborations, and one of them is this chain of custody monitoring. So, on top of the mobile gateway, we're providing a way for what we're targeting specifically right now is insurance and high stakes claims. So court evidence and things like that, things that require what's called chain of custody. So you need to know who has ownership and responsibility of these items during their storage and transportation. So by providing insurers with eyes and ears of their evidence and assets during these times of previously dark periods, we essentially provide them with another, for lack of a better term, bullet in their barrel when it comes to arguing their cases in court, because now they can say without a hash of a doubt that their assets haven't been tampered with while in storage, right? So that's what we're really offering them, and that's sort of the first custom device that's going to be running on our mobile gateway and the Helium network, for that matter. On top of that, also with Plymouth Sound, we're looking at autonomous weather routing for shipping. So currently the way that ships, they gather data is manual and completely voluntary process, and it's highly subjective. So what we want to do for the autonomous ships of the future is provide them with accurate weather data, and that would be by providing them low power weather monitoring solutions, and that will be fed into a system that can essentially provide a dynamic and live weather routing to reduce fuel consumptions and improve efficiency. So that's the mobile gateway is our main project, but some of these are obviously spin-offs and have evolved around that concept.
Yeah, and we also have the incentivized safety management system. Right now, at the moment in industry, safety management systems, they typically operate on one of three models. There's either the blame culture, the no blame culture, or the just culture. And their names are pretty self-explanatory, but on the gist of it, essentially the most favored one today is the just culture, because the blame culture, really, it's just about if something goes wrong, we just blame the guy who did it. It doesn't matter what the problem is. We don't learn anything from it. The no blame culture is something, if something goes wrong, we don't actually blame anybody and nothing ever gets resolved. We don't learn anything from it. But the just culture is about reporting and actually, providing a safe culture within the industry, and also not invoking blame. So it's a non-punitive sort of system. And while it is the best that we have at the moment, we intend to add an extra layer to that. So one of the extra layers is the incentivized model with the blockchain, which will allow essentially, it'll allow incentives for the employees to adhere to and to report certain safety issues along the way. And you could also imagine a whole bunch of sensors that put information into the system, which would then create a new ecosystem and a completely new environment for the employees to collaborate on. And so our other project, which is mentioned here, is the wildlife technology. And we're working in collaboration with the Maholo Holo Rehabilitation Center, which is where Stoffel lives. And together with Brian, who runs the Maholo Holo Rehabilitation Center, and his son, Colin Patrick, who is actively involved in anti-poaching efforts at the moment. And he directly works with the South African police to apprehend poachers, especially that are looking for rhino horns at the moment, because due to the coronavirus, it's strained a lot of people. So together with them, we're developing technology, and also together with Imperial College, we're developing some technology which would allow us to track the poachers instead of the animals. Because if we begin tracking the animals, essentially it makes it open for corruption. So we'd rather know where the poachers are than put out on the internet or on any kind of system where the animals are at any one moment in time. So that you can check those links that are at the bottom of the slides there, if you want to go and see anything more about Colin and Brian and Maholo Holo.
And the background on the Mahalo Holo collaboration was that you guys just literally reached out to that group and said, "Hey, we like Stoffel and we like building technology. How can we help?"
Pretty much,
Yeah.
exactly. Yeah, we wanted to help them, and well, we called them, and we just wanted to sort of, get to know them, and then they said, "Hey, we've got a lot of problems. Help us," and we said technology can help, and we'll do that.
That's super cool. Yeah, maybe we can drop some links to those in the chat. I'm not sure if Emily can do that while we're talking. Okay, so I think we should probably kick it into some Q&A here. I got one more slide here from you guys if you want to just sort of
that's the last slide.
Just the final slide. So quickly, Stoffel bridges the gap between development and industry, mitigating risk by ensuring bidirectional exchange of innovation and real-world application. So our intent is to really foster mutual collaboration to promote development and adoption on a rapid scale. That's pretty much it.
And I think the main purpose here today, aside from the Q&A session at the end here, is to present ourselves and to sort of start the conversation, because we're at a stage now where we're sort of feel like we're ready to do that. And what we want to do in the first instance is engage with members of the community who might be interested in helping us build Stoffel, and to begin discussing how our mobile custody gateway and the accompanying protocols can potentially complement the People's Network. And that's what we've been working with Mark on, and what we'll continue to try and roll out with all of your help here. And in addition, we're looking after Plymouth, we're looking to expand our test net. And so we're also looking for industry partners that are willing to provide the necessary physical infrastructure to help us deploy a large-scale test bed for some of our projects. And yeah, I think we'll round it off there. And just if anyone's listening and wants to reach out, feel free, collaborate at stoffel.net.
Cool. Okay, so you're looking for people to help eventually test new pieces of technology and the infrastructure.
The reason I'm
develop it.
listening.
Yeah.
Okay. All right. So let's, so there's an email address, collaborate@stoffel.net. And then I can also route requests if people want to email me directly to Chris and Fleming in the group. So, all right, let's do a little bit of Q&A. I'm going to switch to the last slide here. So I think we've got 4 or 5 minutes. So actually, I'm going to start with a question for Adam to really throw him off his game. So, you've been prototyping basically connected devices on the Helium network, where you mentioned Arduinos and Raspberry Pis. Any sort of advice you want to give to people who are just getting started building a connected device, prototyping something from the ground up? Any sort of wit and wisdom you can share?
Yeah, it's really interesting. I think something we found useful was we looked a lot at the white paper initially from 2018 about how the blockchain mechanics of the Helium stuff worked. I think we found that was probably a mistake. It's probably more.
But bless your heart,
it's more worthwhile to be looking at more recent stuff, as in like the Providence stuff. There's definitely a model of getting that working with what exists the blockchain now. But I think we got overly interested in how proof of location worked, or it was originally intended to work, rather than how it works now. As in, there's definitely a space for verifying locations on the blockchain, but with state channels and with kind of the changes in how proof of location works, it really makes more sense to look at what's going on in the APIs, in the code now, rather than the white paper.
Yeah, for those of you who have not read the white paper, which is probably most of you, not a problem if you haven't, we did talk a lot about proof of location and something called time difference over the air, TDOA, in the white paper, which still can be done on top of LoRaWAN, but is a lot messier and more complex than most people sort of gave it credit for, or anticipated rather. But you should all go read the white paper. It's out there. If you Google for Helium Network white paper, it's quite a good white paper, even in my very biased opinion. But yeah, so we do have some work coming specifically on features that will sort of expose more blockchain specific primitives around, like using a blockchain exposed API for that exact thing. Which is going to be super useful for this group and other people who want to use that. So, okay, so don't read the white paper. Start with more current documentation. Anything else?
I think just to nothing else, but to qualify that, I think white paper is interesting. It's definitely where we jumped off from, as in our interest in doing the blockchain stuff comes from that. But look at the more recent stuff as well.
Cool. Okay. And a shameless plug for Discord. If you're not in the Helium Discord server, it's just discord.gg/Helium. That's where pretty much all of the real-time development takes place for the network. So definitely join that if you want to get involved in those. It's like different channels for sensor development, Helium console, blockchain protocols, all these things. All right, so we got a couple questions here that have come in over the chat. So one that came to me privately. So if you put hotspots or your mobile gateway on cargo ships, are you potentially looking at picking up LoRaWAN communication from other passing ships? Like, could you end up providing backhaul for other things? I think the answer is yes.
Yeah.
Yes,
Yeah. Correct.
that is the answer. Yeah.
Yeah, that sounds. I mean, I'm not familiar enough with the shipping industry to know how much actual traffic is out there. But I mean, how often are ships just? LoRaWAN has extremely large range, especially on the ocean, right? So you can see picking up a signal from 15, 20, 50 miles away. I mean, how often are ships getting that close to each other in open water?
It really depends on the area, but I mean, you have these choke necks and bottlenecks, let's call them, around the world, Singapore Strait, Malaga Strait, and so on and so forth, the English Channel, where you have hundreds of ships at any one given point in time, and then you have places like the middle of the Pacific Ocean where you're not going to meet another ship for a few weeks. Yeah. So it's a bit of mix and match, which is also something we're taking into consideration in the designs of this.
Yeah, one other thing we're also taking into consideration is the fact that once it's deployed in industry, we might, it'll become more interesting for pleasure craft, for example, to solve a bunch of problems that they have. So yeah, it'll increase the footprint out on the water as well.
Interesting. Yeah, I'm just envisioning, God, you can make LoRa go so far on the open water. It's fantastic.
Making it go to space now.
Yeah. Okay, so Fred is asking, or I guess suggesting that the bandwidth of LoRaWAN is pretty limited for reporting about hundreds of containers of a ship compared to something like Starlink. I don't think that's wrong, Fred.
No, it's not wrong.
No, that's true.
But I think Starlink specifically is very interesting from a hotspot backhaul perspective. I mean, it'd be very, very interesting to get any satellite backhaul. I don't think. So there's one project from a company called, there's Lacuna Space, which is part of the LoRaWAN ecosystem. They've got a satellite backhaul rather for gateways. There's another one called, I think, Ambisat, Ambisat maybe, AMBSAT. I might be butchering that. That has looked into working with Helium. Starlink would be fantastic. I mean, it'd be very, very cool to get a Starlink backhaul on a hotspot or on this mobile gateway of yours.
Yeah.
Well, we've got a Starlink satellite coming, and we're going to be deploying it in Plymouth Sound. So maybe there's an opportunity.
Yeah.
Dish face. We're getting. He's coming.
All right. So another question that just came in. Let's see here. So we just kind of addressed this, but what are the requirements for mobile gateways in terms of sending info to land-based apps for tracking? Do you need internet and satellite connection? So yeah, I mean, so to get data off of a ship or something that's not land-based, you'd have to have some sort of backhaul. Could be cellular, depending on where you were in terms of coverage. It could be satellite, but that would be a requirement for sure.
Yep.
Okay. I mean, you guys have any questions for me? Any burning questions about Helium and the future of the network or something like that? Don't ask me anything that's going to cause Emily to get upset at me for sharing a roadmap that's not public. Anything I can answer for you?
For us,
from our side, we're nothing from us.
Okay. Adam, anything on the sort of usage and developer tooling side that you think we're short on? Like any features?
I think the Discord has filled a lot of holes for us, at least, is
Good.
trying to connect stuff. And
Yeah.
But the developer toolkit is definitely changing a lot recently, but it's all very good. Like the docs have all been changed.
Yeah.
But it's
Awesome.
Cool. Okay. Well, with that, I'll thank Christian, Fleming, and Adam for giving us 45 minutes of their time. You guys are extremely busy. So we thank you for informing the community about what's going on. So I think we will, so emails are on the screen here, Christian at Stoffel.net, Fleming at Stoffel.net. I am Mark at Helium.com. And any last words, guys?
Yeah, no,
That's it from
thank
us,
you
I
very
think.
much. Yeah.
Thanks for joining us.
everyone.
Yeah.
Thanks for your
and
time, Mark.
Thanks for being part of the network. You guys are fantastic.
Yeah, and thank you for
Oh, that's
making
awesome.
it.
Thanks for the opportunity.
All right. And thanks for everybody for joining. We'll talk to you soon.
All right, have a good
Take
one.
care.
Bye, everyone.
Bye.
Bye.